I'm John Gudmundson, and I'm in the A10 product marketing team. And I rather imagine pretty much everybody here has issues or potential concerns about client authentication, also around AAA server scalability, around things like authentication point proliferation, and also concerns about support limitations for the latest and greatest authentication standards. So I'm going to briefly talk about how we can help you substantially improve your authentication process for client-server traffic. I'm also going to talk about how you can offload a lot of the normal processing requirements off your traditional application, AAA servers, and so forth, onto a separate device, and ultimately how to maximize, improve and centralize your authentication setup, your system, as well as ultimately save cost. So today, it goes without saying that authentication is a critical component for any online communications. You've got to be able to validate, the client has to validate itself, and ultimately the respective target server that this client is trying to reach. But in the process, what we're seeing, things that complicate this whole authentication process, is the fact that there's a major move to the cloud, as well as bring your own device. And on top of that, customers now not only are using very mission-critical applications, but many times these applications are not only standard off the shelf, but custom applications, as well as on-demand type applications. So that further kind of complicates the situation. Beyond that, you've got a whole slew, kind of alphabet soup, if you will, of standards, and those are things that you're going to have to deal with if you're not already, certainly in the future. Obviously, Kerberos is there, but SAML is something that you may have or you're looking to do, OCSP, and so on. Now, today, you'll take your typical kind of high-level infrastructure with the user, various type of access devices, a generic load balancer, your web and application servers, your AAA servers. And traditionally what happens is, of course, requests come in, they go to the generic load balancer, they're shifted over to the AAA server in order to get authenticated, then the client is allowed into your network. But what you'll see is before long, oftentimes, because this device here really isn't doing anything other than just dumb load balancing, you're seeing a lot of the processing take place on the web and application servers and your AAA servers. So as a result of that, these things start to heat up, they start to get higher utilization rates, your CPU levels go up, such that now, at this point, things don't look too bad. You may have a 50% CPU load or something, but you're still at least able to get authenticated, clients getting authenticated, and they're ultimately getting the data. But now what happens when you start to continue the process and scale more and more users, what you'll find is eventually, because you're not offloading anything from these servers down here, eventually your servers are completely get maxed out, not only for the web and application servers, but your AAA servers, CPU utilization levels redline, and you got basically a mess. So eventually what happens is the poor client here is getting nothing but 404 errors because they're not getting authenticated, they're obviously not getting their data they're requesting. But there is an answer to this, at least to help offload a lot of the efforts these servers are doing onto something else here. So that's where basically what we call an application delivery controller solution comes in. So I'm going to briefly give you a little bit of an overview of what that is. So an application delivery controller is a device that sits in your network, typically very close to your web and application servers deep in the network. And you may very well be using one today, but you can also find them in the demilitarized zone, the DMZ as well. But what they typically do, and there's a whole slew of benefits that app delivery controllers bring you. One main benefit is availability. And what I mean by that is simply it makes the servers available. So instead of having some dumb load balancer that just blindly sends incoming requests to a particular server, it actually goes and finds out the server that's best able to handle that particular response. So it's looking and it's guaranteeing that the server that's sending the request to is actually available, not just at lower layer, lower levels where a ping, say, will work, but all the way up the stack and even beyond to the data backend database servers. So it's periodically checking to make sure that before it sends a request that the servers are actually functioning. And it can do this at layer 7, so that gives you the ability to more finely, to look deeper within the packet and say, okay, this particular user is looking for a particular service, and it sends that request to a specific server that can handle it. And what that ultimately does is it allows you to cut your server farm size by 50% or more. We've seen repeatedly, time and time again, customers say, using ADCs, cut the servers down substantially. We also have something called global server load balancing. So in the untimely event that one of your data centers just simply goes offline for terrorist attack or whatever it may be, earthquake, then global server load balancing will help you ensure business continuity by forwarding those requests to another data center. And the end client doesn't realize it. It's all transparent to the client. This will then help you scale also your web and key infrastructure up. Another thing is acceleration. So imagine you've got a request coming in for a very chatty application, and you're halfway around the world. You've obviously got the limitations of literally the speed of light is not infinite, so you're causing delays inherent in these requests and the ultimate response. So what we're able to do is to take advantage of a whole slew of RFC standards on the WAN protocols call side. So, for instance, if you're familiar with selective acknowledgement or fast ramp or client keep alive and so on, what that helps do is kind of overcome some of the bottlenecks and issues of the traditional internet communications, and actually makes, in some cases, the application appear much more almost as if it's local to the user on their own local area network and not on the wide area network. And this helps obviously achieve your service level agreements. Of course, offload a lot of overtaxed servers because now you're handling TCP/IP, you're handling massive amounts of SSL, and as we'll see, a lot of authentication processing on the ADC. And because of compression, we're able to also drive down the WAN bandwidths involved, which also indirectly helps with improve the acceleration because now you're not getting a lot of packet collisions and things going on with much less data actually going through the network. Perhaps most importantly to you people here would be the element of security. Now, you're probably familiar, obviously, with the next-gen firewalls and IPSs and all those sort of things. But one thing that we do at A10 and our app delivery controllers is we include a web application firewall. And that blocks attacks that specifically target the application and their weaknesses. So next-gen firewalls, IPSs, et cetera, endpoint security doesn't handle that. So if you have a SQL injection attack, if you have a cross-site request forgery, if you have a cookie poisoning or forceful browsing, and dozens of other application-level attacks, the only way you're really going to stop it is with a web app firewall. Now, in some cases, if you're in the financial community, for instance, the payment card industry will probably require you to have either an app firewall or an ongoing code audit of the applications to ensure they're not vulnerable, which obviously is vastly more expensive than a one-time web app firewall installation. We also, of course, block high-volume DDoS and protocol anomaly attacks. So this is the high level, but one thing that's great about at least A10 app delivery controllers is you can do all of this and more at over 100 gigabits per second of layer 7 traffic. And in addition to that, we can offload tens of gigabits per second of SSL traffic because we have hardware-based SSL cards within the ADCs. And even hundreds of thousands of SSL transactions per second can all be managed by the ADC. Now, I mentioned the offloading. So not only the TCP/IP gets offloaded on the ADC, the SSL gets offloaded, but also authentication. And not only that, but these come in a 1 to 2 rack unit appliance. And like I said, they sit deep within your network. So imagine that being able to replace a whole slew of discrete point products and put in one ADC that does all this at the same time. Now, let's take a look at edge authentication. And initially, I'm showing your generic load balancer that I showed earlier. But when I replace the generic load balancer with app delivery controller with our application access manager module on top of it, which is included, it's just one license, get you everything. Now just kind of going through the process here where a request comes in, you'll immediately see that it's proxied on the ADC, so that kind of adds a layer of protection to your servers. Then the AAM itself then sends a challenge back to the user. And in a form-based environment, you'll see a little pop-up window saying, okay, enter your credentials, the usual things. The client enters that, goes back to the client, goes back to the AAM. That gets sent over to the AAA server. So whether you're running Kerberos or SAML or what have you, the AAA servers then actually look at it and say, okay, this client is authenticated or not. Assuming they're authenticated, it comes back to the AAM, which in turn forwards it on to the web and application server where the access is granted. So it may not be obvious, but a lot of processing that normally would take place around here is happening here. And like I said, you're also, by proxying these connections, you're adding one layer of protection to your servers. Now let's look at how we can simplify expenses or reduce expenses and kind of simplify the whole process here. Going back to the generic load balancer example, again, your web app servers, your AAA server. Now, in this scenario, what you're going to have to do is add authentication points to all of these servers here. Now, the problem here is, of course, you've got to add, you've got to install, you've got to configure, you've got to maintain each one of these authentication points, validate that they work with the applications running on these servers, validate that it works with the AAA server. So it's a lot of pain, it's a lot of hassle, and you'd rather not have to put that here. And every time you change an application here, suddenly you got to go back and kind of do the same process over to make sure this authentication isn't causing problems with the applications. Then SSL certificates, because you're not doing any SSL basically up here, you're now loading it on your server, you got to have SSL certificates on each one of these. So massive duplication of the certificates, but also somewhere you've got an excellent certificate management solution, and they have to discover where all these certs are, make sure that they're valid, make sure that they're not out of date, etc. So that kind of, by having them here, it's just one more level of complication for your overworked certificate management solution. So now let's say, okay, let's get rid of this. Let's say, all right, now we put back in an app delivery controller with the AAM, and magically we can take all the authentication points, all the SSL, and throw those up onto the app delivery controller. So that cleans this mess up, that simplifies your cost structure, and basically reduces the number of SSL certificates. And once you make changes to applications here, you don't really have to worry about some interference or some interoperability issues with the authentication running here versus here. On top of that, the A10 device, the app delivery controller, comes with a dashboard, which allows you an enterprise-wide view showing what all the policies are and events that are taking place. So it simplifies and gives you a broader view of what's going on without having to deal with all your infrastructure down here. Another thing is, if you change your AAA server, if you update it and so forth, that causes another issue where if you didn't have authentication running here, you have to go back and validate an interoperability with the AAA with all this authentication down here. So again, it's much easier if you want to change here to with a very simple policy changes on the AAM. It's a much more simple process. Now let's talk about server availability. So in this situation, I won't bore you with a litany of server load balancing. I think it's a pretty familiar concept. And most likely you're familiar with things such as health checks, server monitoring, and so forth, where basically the A10 ADC is periodically checking the status of all of the servers, not just your web and application servers, but also the AAA servers. So kind of behind the scenes, you're seeing requests going to those AAA servers, and then the ADC is saying, okay, what AAA server, or even also what web application servers are having any issues? Well, you see in the first case here, the component was lost to server 1. That can mean the server 1 is really hosed, or it can mean the link to the server 1 is down. So irrespective, you didn't get anything back. So the ADC knows, don't send any authentication requests over to server 1. Forget about that one. Server 2, well, you got a problem detected. There was, you maybe didn't notice, but a red packet comes back to here and says, look, server 2's got an issue. Somewhere up the software stack, there's a problem. Don't use server 2. Server 3, it's healthy, it's functioning. We'll send authentication requests there. Now, with a little bit of luck, you've never seen a disaster scenario where 70% of your AAA servers go down. Hopefully, you've never experienced that, and you never will. But in the event that it happens, this behind the scenes is ensuring that these authentication requests are going to go to a functioning AAA server as well as a web and application server, ultimately for the content. Now, obviously, single sign-on is an important topic, and if there's one thing the poor client here dislikes more than having a delayed authentication and delayed content, it's the fact they have to keep entering their user credentials. And I'm sure we've all been there, constantly entering your credentials. They don't want to see that. They want to see a single sign-on. So with SAML, what SAML does is it provides a secure way to send information back and forth between the service provider, which is AKA the ADC, the app delivery controller, and the identity provider, AKA the AAA server on the other side. So SAML is a very nifty way to do authentication and achieve single sign-on, and we at A10 basically support the use of SAML. So again, request comes in, and what happens is once it hits the AM will go ahead and send a SAML a request for authentication over to the identity provider, the AAA server, basically. And assuming that user was in fact validated, then you'll actually see a SAML assertion coming back to the AM module. It'll be encrypted, and there'll be a certificate there, such that then once it gets to the AM server, then ultimately it's unencrypted and sent to the web and application servers. Now, also behind the scenes, you're seeing cookies installed in such a way that for the next time the authentication, this client tries to get authenticated, he or she's already been authenticated. And even if that client moves to different locations or does other things, they're already pre-authenticated, so they're done entering their user credentials. So lastly, I want to talk a little bit about interoperability. And basically, it's absolutely important that a solution such as an app delivery controller is, in fact, validated with a host of identity providers. So what we've done is we worked hand in hand with a lot of vendors that are actually obviously here at the show, starting, of course, with RSA. But there's a number of them here that we've done full testing, interoperability testing, and we've got reports that can show this, installation guides that can help you walk through the process of how to utilize ADC with the various identity providers. And in terms of whether it's a service provider initiated or identity provider initiated, it works either way. And of course, regardless of the authentication scheme you're using, whether it's form-based, Kerberos, even NT LAN Manager, which is pretty archaic, but still some people have it out there. SAML, LDAP, obviously Radius, traditional authentication schemes, we fully support that and validate it.